All right, we are here 2.5 second part, which is finding the equation of a plane. To find the equation of a plane, you have to have a point on the plane, and you have to have a vector which is normal to the plane. All right, normal vector to the plane. So if you think about like a plane like that, and there should be a vector. I can draw that vector here. There should be a vector which is perpendicular to the plane. All right, so that is perpendicular to the vector. So that means that vector could be over here anywhere, but that's as long as they're perpendicular to the plane. And there should be a point. I should have a point on a plane, on the plane, right? So the idea here is, let's see, a P is a point on the plane, and we just find a random point on the plane. All right, so let me draw this again one more time. So let's see, if I have a plane like this, there is a P is a point, and then there's a, we just randomly choose a Q point on the plane. All right, so if I draw that, if I draw a vector there, PQ vector, that's going to be like a P is right again, P is a x naught, y naught, and z naught, and Q is a point x, y, z. All right, so if I write down PQ vector, and that's going to be x minus x naught, y minus y naught, and z minus z naught. All right, z0 or whatever that. So that is a PQ vector, right? Now, if I know a vector which is perpendicular or orthogonal to this plane, all right, so let me draw with a different color. So there is like a vector somewhere which is perpendicular. So let's see, the vector is like that. I don't know why it's called curly. So that is perpendicular, this one, all right? Could be anywhere, like a, maybe it's just as long as it's perpendicular, right, to the plane. Then we can figure out what is the equation of the plane, right? So again, let's see this vector, the perpendicular vector is A, B, and C, right? That's perpendicular vectors, which is, we call it n vector, right? This is like a small n, mostly represents a unit vector, a unit normal vector, but doesn't have to be unit there anyway. That's a normal vector to the plane, all right? So I'm going back here. A, B, C, that vector, dot with the PQ vector. This is a PQ vector. If you do the dot product between these two, normal vector to the plane and PQ vector, it's going to be always 0. Because, you know, dot product between two no perpendicular vector is going to be always 0, right? And then the dot product is A times the first component, B times the second component, and then goes like that here, okay? And that's how you set up. So then what you can do is, I mean, it's coming here, then you can multiply this one. You can, it looks like this, right? AX plus AX naught plus BY, BY, is that a negative? Should be negative here, right? Negative. Minus by naught plus cz minus cz naught should be equal to 0. All right. So if I put together this one, like I could write down ax plus by plus cz minus, can I just combine this one? Ax naught plus by naught. I'm just pulling out all the negatives, and then plus cz naught should be equal to 0. All right. And now this whole thing, let me change the color here. This whole thing, we call it D. All right. So then you can add D on both sides, and you're going to get this results. All right. And that is the equation of a plane. All right, so remember that this equation of a plane, this is equation of plane. And remember that what is the normal to the plane is A, B, and C vector is a normal to the plane. All right, and remember that D is this whole thing is your D. Okay. All right, let's look at one example. All right, let's look at one example. I'm going to come here. Example number 3. Okay. So find the equation of a plane, passing through this one. So I'm just going to make a one plane, right? And then passing and then perpendicular to the vector. So you have a normal vector, which is a k. And do you guys remember the k vector? What is the k vector looks like? Remember that this one is x, this is y, this is z, right? There's just like a unit normal vectors, like this one we call it k vector, and this one we call it j vector, and this one we call it I vector. Remember that I vector is a standard normal vector, which is 1, 0, 0, because you have a x towards x, that's a 1 unit, and then other is 0, 0. J vector is 0, 1, and 0. Okay, and k vector is 0, 0, 1, right? So k vector is perpendicular to the xy plane. Right? I don't know, do you guys notice this? This is your xy plane, and then k vector is always perpendicular to xy plane, right? Remember the same thing. I vector is perpendicular to yz plane. Think about like this is yz plane, and then your I vector is perpendicular, right? Same way, the j vector, this vector is perpendicular to xz plane, right? Think about like a one of the wall, right? All right. So here, I wanted to figure out what is the equation of a plane that has a point and perpendicular to the k vector, right? So I think this one is like I don't know, do you guys see this? So perpendicular vector is this is the perpendicular vector, right? K, this is n, which is happen to be in this case is k vector. All right, so n is k. Now if I wanted to find the plane, is that plane is this one, this plane has a point 0, -1, 4. So they're like a 0, -1, 4. So let me be something like the 0, -1, and 4. Remember that that's a point on the plane, and that plane is perpendicular to the k vector, right? So what is the equation of the plane going to be? Remember, let's use that formula, right, where we just did it. Okay. All right, 0, 0, 1 is the n vector. Okay, dot with a vector, like I want to find out x, y, z, a point on the plane. So x minus 0, y minus -1, which is +1, and z minus 4. That is the vector, and if I do the dot product, I should get 0, right? You guys see that? So if I connect this one, that's the vector on the plane. That vector is perpendicular to the n vector. That's what given, right? It says in the question there. So that means the dot product should be 0. So if I see 0 times this is 0, plus 0 times second one is 0, and third one is plus z minus 4 should be 0. So z equal to 4. You see that? Z equal to 4 is that plane, right? This plane is z equal to 4. I don't know if you guys remember from the first class there, z equal to 4. It's kind of delay writing here. Z equal to 4. I'm waiting here. All right, z equal to 4 is that line. Okay. Okay, waiting here. Okay, z equal to 4 is that plane. Okay, so my final answer is going to be z equal to 4. All right, I know I stopped writing at the end. Z equal to 4 is my final answer. All right, I'll stop here.